Hello students, how are you? Last week we have tried to discuss about matrices. What is the definition of matrix? The order of matrix. How to find the sum of two matrices. And how to find the scalar multiple of a given matrix. Today we are trying to see about multiplication of matrices. If A is a matrix, Aij is an M by P matrix, and B is Bij is a P by N matrix, then the product AB is a matrix C of order M by N. What does it mean? You are given that a matrix C is a product. AI, it is any row. Bj, it is the given matrix. Before you are multiplying, you have to check that the number of columns of the first matrix A must be is equal to the number of rows of the second matrix B. Here, A is a matrix with order M by P, so P it is the number of columns. B is a matrix with order P by N. You have P is the number of rows. Then, when these two are multiplied, you will get a new matrix with order to be the number of rows of the first matrix M by the number of columns of the second matrix N it will be. So we'll see how is it possible to find the product next time. Next, also what we are looking about determinants. The determinant of a 1 by 1 matrix. A is a real number A. What does it mean? If A is a matrix, 3, this is a 1 by 1 matrix. Then, what is the determinant? The determinant of matrix A is equal to this one, matrix A it will be, which gives the determinant of 3. It gives a real number, 3 by itself. If you take that, if B is a matrix, which was represented by -5, then what is the determinant of B? We can represent this one, which means the determinant of -5. What is this one? It is a real number, -5. Take care. Absolute value and determinant are not the same. Second, what you are looking, how to find the determinant of a 2 by 2 matrix. When you are given that A is a matrix, AB first row, CD second row is defined to be the number AD minus BC. What does it mean? The determinant of matrix A with order 2 by 2 is equal to, I can represent as the determinant of A, which gives the determinant of A, B first row, C, D second row. How do you find? You have to multiply the two main diagonal elements, A times D minus the opposite diagonal elements, B, C it comes. The difference between these two products, which is AD minus BC, it is said to be the determinant of the given matrix it will be. We can see some activities. In the previous, since we have discussed about matrices, A it is a row matrix, B it is a column matrix. What is the product? To find the product, first I will check what is order of this matrix A. It has only one row by number of columns to be equal to 3. B is a column matrix with size. It has 3 rows and only 1 column. So multiplication is defined because the number of columns of the first matrix is exactly equal to the number of rows of the second matrix. So what would be A times B when you say it is a row matrix 4, -2, 0, multiplied by the column matrix -1, 8, and 7 it comes. Then what are you going to do? Multiply the first element of the row by the first element of the column. 4 multiplied by -1 plus second element with the second one, -2 times 8, plus third element by the third one, 0 multiplied by 7. This sum, it gives the product of the two matrices. What will be the size? The first column, matrix A has row 1, second matrix has column 1. It will be 1 by 1 matrix. When these are added up, 4 times -1, -4, -2 times 8, which was equal to -16, 0 times 7 to be equal to 0. You will have a matrix. When this is added up, you will get a 1 by 1 matrix to be -20 it will be. If you want to see that, how it was calculated, what I have done before, row by column, you are multiplying each element of the row with each corresponding element of the column matrix. Then you are adding up. You will get a value to be equal to -20. It is a matrix represented by this product. It will be. You should have a bracket over here, because it will be a 1 by 1 matrix. What I have, 1 by 1 matrix. Let's see the next one. How is it possible to find the product of A with B? A, it is a matrix having size 2 by 3. B is a matrix having size, it has 3 rows by number of columns to be equal to 2. So number of columns of the first matrix 3 is equal to the number of rows of the second matrix. So multiplication is defined. How do you find the product? You should be able to multiply the first row with the first column. First row with the first column. Then you are going to write a number over here. First row again with the second column. You will get another number here. Second row, when it is multiplied by the first column, you will get another result, which will be written there. Second row with the second column, you will have this one. So what you are looking, each row of the first matrix is multiplied by each columns of the second matrix B. So when these numbers are considered, you will have a matrix having a size 2 by 2 it will be, which is the number of rows of the first matrix and the number of columns of the second matrix it will be. What are these values? These values can be calculated as follows. A times B. Then see what it looks like. First row multiplied by the first column. First row with the second column. Second row with the first column. Second row with the second column. This is row by column. Row by column it comes. Then what we have? When these are multiplied, you will get a value here. When this row is multiplied by this column, you will get another result. Second row with the first column, we have this one. Second row with the second column. And when you are looking, you will have the sum. When the sum is calculated, -6, 16, -8, 26. So multiplication is defined. The product it is a 2 by 2 matrix it will be. The other one, let A be a matrix 3 by 3. This was 3 by 3 matrix. B is another matrix which has 3 by 2 it will be the size. Then is multiplication defined? What is order of A times B? So to discuss about the order of matrix AB, multiplication must be defined. And what will be the size? Since the number of columns of the first matrix A is equal to the number of rows of the second matrix. Multiplication is defined. So what will be the order? The number of rows of the first matrix 3 by the number of columns of the second matrix it will be. A is a 3 by 3 matrix and B is 3 by 2 matrix. Then AB it will have a 3 by 2 matrix. Then the order of AB it is 3 by 2 it will be. The other, what you are asked, the product of the two, A times B, it was represented by C. What is the element given by C, 3, 2, the entry, one element in the product. This means it is a product which is formed by the third row of matrix A by the second column of matrix B. Because C is the product of the two, A times B it will be. So, what is a C, since the product it is a 3 by 2 matrix, you are asked what is the element in the product which is present or which is found in the third row and second column, which was A3, B2 it will be. What is A3? A3 represent the third row of the given matrix. It is A3 means the third row, this one. B2, it is the second column of that given matrix. So I have to multiply third row by the second column to get this one. And this was a row matrix, column matrix. Multiplication is defined, 0 times -4 plus 0 times 3 plus 3 times 0 it will be. When this was added up, you will get a result to be equal to 0. That means in the product, the element which is found in the third row and the second column will be equal to 0. See what you are asked. What is this element in the product? In the product, C21 means it is the product of the second row of matrix A by the first column of matrix B. So what is that? A2. A2 it was this one. 1, -1, 0 represented by A2. B1, it is the first column of this given matrix, this one. 1, 2, 4 it will be. When this row is multiplied by that one, you will get an element in the product, C21. What is that product? Let's see. This is second row of matrix A. This was first column of matrix B. This is row matrix by column matrix. Multiplication is defined. 1 times 1 plus -1 times 2 plus 0 times 4. When I multiply it, I will have and add up. I will get a result to be equal to -1 it will be. So, what is the order of the product? The order of the product is 3 by 2. What is the element? C32. We have calculated. C21. The result to be equal to -1 it will be. The fourth question, what you see, you are given that matrix M and matrix N. Then find the transpose of M. Transpose, it is a new matrix formed by interchanging row by column, column by row. So M is a 2 by 3 matrix, 2 by 3 matrix. When I discuss about it is transpose, I will get a new matrix. First row, it will be first column. Second row, it will be second column. So you will have a size 3 by 2 it will be. You are asked the transpose of the transpose. The transpose of their sum. The sum of the two transpose. Transpose of M plus the transpose of N. What is that? You can see turn by turn. For the first one, M, it was given a 2 by 3 matrix. Then A, what is the transpose? This matrix must be transposed. So first row, it will be first column. Second row, it will be second column. This was the answer for A. What is the transpose of M? Second, What is the transpose of the transpose? We are taking 2 times. So M transpose, it was this column. You have 3, -1, 2, 4, 5, 6. When this 3 by 2 matrix is transposed, what is that? First row, it will be first column. Second row, it will be second column. Third row, it will be third column. So what you have? M transpose, it was, you have a matrix 3 by 2, whereas the transpose of the transpose, it gives 3, 2, 5, -1, 4, 6. The size of the result, it is 2 by 3. And when you are referring matrix M, it was this one. The transpose of the transpose again, it was this one. When you compare these two, the two values are equal. So we can conclude that the transpose of a given matrix always is equal to M. I hope you do remember that when you discuss about relations. We have a relation R, the inverse. When I consider again the inverse of the given relation, it gives the original relation R, it will be. The same thing also true for any matrix M. The transpose of a given matrix will be equal to the original matrix M, it will be. See, what is the sum of the two? M, we have 2 by 3, 2 by 3, and it is also again 2 by 3. They have the same number of, the same order, so they have the same order. So we can add up as we have discussed before. Add respectively first row with the first row element of the second one. 3 plus 7, 2 plus -4, 5 plus 0. Second row with corresponding elements of the second row of the second matrix. -1 plus 5, 4 plus 8, 6 plus -2. When these two are added up, you will have a result. 10, -2, 5, first row, 4, 12, 4, it is second row. This is the sum of the two. What is the transpose of their sum? Since the sum, it was a 2 by 3 matrix, when this matrix is transposed, you will have first row, it will be first column. Second row, it will be second column. So this is the result, what we have expected, the transpose of M plus N. Take the other one also. The sum of the two separate transpose. M transpose, when this one is transposed, you will get a 3 by 2 matrix. The transpose of N, when this one is transposed, will have a result to be this column, matrix. When these two are added up, since they have the same size, 3 by 2, 3 by 2. Add corresponding elements. 3 plus 7, it was 10, -1 plus 5, +4. 2 plus -4, it is -2. 4 plus 8, 12. 5 plus 0 to be 5. 6 plus -2, it is +4. So the sum of the two transpose, it gives this one. The transpose of their sum, it was this one. What we see, these two matrices have the same size, 1. 3 by 2, 3 by 2. Second, corresponding elements of the results are equal. First row, 10, 4, 10, 4. -2, 12, -12. 5, 4, 5, 4. So what is said? Two matrices are equal if they have the same size and corresponding elements are equal. So what will be our conclusion? The transpose of the sum, it is equal to the sum of the separate transposes. The other one, we'll try to discuss about the determinants. A, let it be, it is a 2 by 2 matrix, 1, 2, 6, 4. B, 7, 5, -1, 3. Then, what is the determinant of matrix A? The determinant of the transpose. The determinant of B and the determinant of B transpose. We said that a 2 by 2 matrix, for a 2 by 2 matrix, the transpose it is the product of the main diagonal minus the product of the opposite diagonal elements. So when you are coming to the first one, you can see A, it was 1, 2, 6, 4. What is the determinant of this matrix? Take care, brackets will be changed to this bar. 1, 2, 6, 4. The main diagonal element is 1 by 4 minus the opposite diagonal element is 6 by 2. Then 1 times 4, 4 minus 2 times 6, it was equal to have 12. 4 minus 12, it gives a result to be negative 8. For B, what is the determinant of the transpose? Since A it was this matrix, 2 by 2, the transpose also it will be a 2 by 2 matrix. What is the determinant? First row will be first column, second row it will be second column. So the main diagonal element is 1 times 4 minus the opposite diagonal element is 2 times 6. It gives a result to be 4 minus 12, which gives a result to be negative 8. So what you are looking? The determinant of A it was negative 8. The determinant of the transpose also negative 8. Take from this we can see the determinant of A it was is equal to the determinant of its transpose. When you are coming to C, what is the determinant of B? B it was this matrix. So 7, 5, negative 1, negative 3. The main diagonal element is 7 times negative 3 minus the opposite diagonal element is minus 5 times negative 1. 7 times negative 3, negative 21. Negative times negative, positive. So you have a result to be negative 16. When you are coming to D, the determinant of the transpose of B. But when B is transposed, you will have 7, 5 first column, second row it will be second column. Then what will be the determinant? 7 times negative 3 minus 5 times negative 1 again. But negative 21 minus 1, it was plus 5. You will have a result to be negative 16. So what it says? The determinant of matrix B is equal to the determinant of the transpose it will be. The other what we see, number 6. Let A, B, C, D be an element of real number. And the determinant of A, B, C, D is equal to 4. Then, what is then determine the value of each of the following. If you are coming to A, the determinant of 3A, B, 3C, D. Another one, B, 5A, 5B, 5C, 5D. What is the determinant of these values? So take the solution for A. The determinant of 3AB, 3CD, when you say, since it is a 2 by 2 matrix, the determinant it will be the product of the main diagonal element 3A times D minus the product of the other 3C, B it will be. What you have? 3AD, the product of the main diagonal, minus the opposite 3CB. But this will have a common factor 3. This could be 3 times AD minus CB. This could be expressed in the form of determinant. What is that? 3 times AD minus CB means you have a column matrix AC, another column matrix BD. So what you have? A times D, it gives this one. C times B, it gives the other one. But what you are told, the determinant of this matrix, it was equal to have positive 4. So I have to multiply it, 3 by 4. The result will be equal to have 12. So we can discuss about the determinant of a given matrix in relation with the given information. But here what we see, this one and this one, what is their difference? In exercise A, the first column elements are multiplied by a constant number 3. Only one column it is multiplied. When I multiplied by one column by a constant, you will have a result 3 times the determinant of the original one. 3 times 4. So these 3 affect or change the result. Takes for the other one. We are given this one to be equal to 4. If the two columns are multiplied by 5, what will be the result? You will have a result for that one. Multiply here, 5a times 5d minus the opposite diagonal, 5c, 5d. When I multiply it, these two have a common factor 25 into ad minus 3cb. So this difference can be expressed in the form of determinant. But what was this value? It is already given to be 4. So 25 times 4 will have 100. The other question, if the determinant of 5x first row, y2 second row is equal to 15, what is the determinant of the matrix 5, 3x, negative 2y, 2? What is the determinant? So to find the determinant of this matrix, we are given a 2 by 2 matrix. You apply the formula and try to solve for that given expression. If you are looking here, given, wow, we are given that an information. What? The determinant of 5x first row, y2, it is second row. When this one is evaluated, it gives a result to be 15. What is the definition for this one? This gives a result, the product of the main diagonal, 10, minus the product of the other one, xy. This gives a value to be equal to 15. Solve for the variable. 10 minus 15, it gives a value to be equal to x times y. 10 minus 15, it gives a value negative 5, is equal to x times y. I am not interested on the exact values of x and y, but the product of the two was negative 5. Then, what you are asked? You are asked to find the determinant of, remember, the determinant of 5, 3x, you have negative 2y, 2 it will be. So since it is a 2 by 2 matrix, I will have also the product of the main diagonal, 10, minus the product of the other numbers. Negative 2y times 3x, it gives negative 6x, y it will be. Negative times negative positive. So you will have 10 plus 6 times xy. But what was xy? Xy, it was given over here to be negative 5. So we will have a value to be 10 plus 6 multiplied by negative 5. So you should be able to find the sum of the two. Well, this can be shown in the following form. If the determinant of this matrix it was equal to 15, then you have a result to be 5 times 2 minus xy is equal to 15. 10 minus xy, it was equal to 15. Xy is equal to negative 5. Then, what is the determinant of this one? Go step by step. This gives a result. You have minus minus. It gives a value to be positive. You have a result to be 10 minus negative 30 to be equal to have negative 22 the answer for that question. The other one, compute the determinant of each of the following matrices. We are given that a matrix, 3 by 3 matrices. To find the determinant of a 3 by 3 matrix, we have to remember definition of minor elements and cofactor. Any row or any column can be used as expansion to find the determinant of the given matrix. When you are coming to find the determinant of a 3 by 3 matrix, we have to remember definition of minor elements and cofactors. We can use any row or column as expansion. If we take, for example, for A, I can find the expanded, the determinant of this 3 by 3 matrix. I use first row as expansion. 0 multiplied by the remaining minor element is this one. 0, 5, 5, 8. Second, the sign will oscillate. Plus, minus, plus, it goes on because of powers of negative 1. Minus, first row, when it is crossed with the second column, at their intersection you have a number 1. When first row and first column are crossed, you will get the remaining elements, negative 7, 5, negative 2, 8. Again, plus, plus, minus, plus. You have positive 4. When first row and third column are cancelled, at their intersection you have positive 4. Multiplied by the determinant of the minor element. A matrix which is negative 7, 0, negative 2, 5. 4 times the minor matrix. This is a 2 by 2 matrix. You will have a value to be we have a 2 by 2 matrix. 0 times 8, 0, minus 5 times 5, minus 1 times negative 7 times 8, minus negative 2 times 5, plus 4 times the main diagonal element, negative 5 times 7, minus negative 2 times 0. When this one is added up, you will get a value to be equal to 46 minus 140 to be equal to negative 94. You can use another row or column to find the determinant of this 3 by 3 matrix. The last result, it will be again negative 94. Take B also. What is the determinant of this matrix? The determinant. Still, if I use that first row as expansion, when first row and first column are cancelled, I will have across their intersection, it was at their intersection, you have 2, multiplied by the remaining matrix elements, 1, 3, 0, 1. Again, when first row and second column are cancelled, at their intersection you have 4, minus 4, because positive, negative, positive. When this is cancelled out, 1, 3 is first row, 1, 1, second row. Plus, when first row and third column are cancelled, at their intersection you have 2, multiplied by the minor matrix, 1, 1, 1, 0 it will be. Then these are 2 by 2 matrices, what we have discussed before. You will get the following result as such. You have 2 plus 8 minus 2, it gives a number to be equal to positive 8. So for A and B, a 3 by 3 matrix can be, you can find the determinant of a 3 by 3 matrix. But you have to remember minor elements and cofactors of a given matrix. The other determinants as applicable to solve systems of linear equations, especially 2 equations with 2 variables or 3 equations with 3 variables. Let's take one simple example. You are given this one. Write the coefficient matrix of A. Coefficient matrix A, if I call, it is the coefficient of the variables. X has coefficient a number A1, a number A2. B has coefficient B, B1, B2 it will be. This is what you call is that coefficient matrix. Solve for X and Y. So when I give solutions, the coefficient matrix, it was this one. How do you find the solution set of these systems of equations? I hope in lower grades you remember how to find the solution set of systems of equations simultaneously by elimination method or by substitution method. If I want to use that elimination method, multiply the first equation by B2 and the first equation by B1. So when I multiply the whole by B2, A1 B2X plus B1 B2Y is equal to CB2. Multiply the second equation by the constant B1. When I multiply it, I will get this result. Then, what is the difference between the two? When I found the difference between these two, this will be cancelled. A1 B1X minus A2 B1X is equal to the difference between the two products. But these two have a common factor. A1 B2 minus A2 B1 multiplied by their common factor X is equal to this expression. Then divide both sides by this difference, provided that the denominator is different from 0. And we have C D2 B2 minus D B1, it is the difference of products over A1 B2 minus A2 B1. It is a difference of another product constant. This difference can be expressed in terms of determinant. How? The determinant of CD B1 B2. This could be expressed as A1 A2 B1 B2 till B. But here the denominator it is the determinant of the coefficient matrix. What I have said before, A1 A2 B1 B2. The determinant of the coefficient matrix. The numerator, here a slight change. The coefficient of x are replaced by the constant number c and d, where the coefficient of I remains the same. This one will represent as dx, the denominator to be d. Dx means you have got a new matrix where the coefficient of x are replaced by the constant number c and d. The denominator it was d, the determinant of the coefficient matrix. If the denominator is different from 0, this is a constant number which gives the values of x. Similarly, we can do the same thing for y. I think this rule we call is that Kramer's rule for system of two equations with two unknowns. What is the values of x? Dx over d. What is the values of y? dy over d. What is dy? It is the determinant of a matrix where the coefficient of x represent as it is, but the coefficient of y is replaced by a constant number. I think, students, Kramer's rule can be applied also for systems of equations having three equations with three variables. You can refer your text to get more idea about these problems. Thank you for today.